Well, good morning. All right, that didn't go well. Let me try again. Good morning.
Good morning.
All right, that's better. I was just not sure if I was here or not. All right, so I want to talk a little bit about some things that we run into quite often. We are not only looking at new languages, we are looking at evolution of languages as well. And I work with a number of developers, and one thing I hear from developers quite often is about how they get really stuck with various different syntax and how they get stuck with certain ways to perceive things. So I want to talk about why we should really go a lot more beyond syntax and start really looking at the semantics. Before I do that, I usually have somebody here just to walk with me here on the stage. So somebody I would prefer that I don't know, maybe I've not met before. So who wants to come and join me here? Don't be shy. One person is running out of the room. That is not encouraging at all. That's okay. Another person running out. Oh, you're coming over here. All right. That's good. Excellent. Come on over. Awesome. I thought I was scaring people. Excellent. Is this the first time in GITS?
Yes.
Awesome. Welcome.
Thank you.
Excellent. Excellent. So you write code, I assume?
Yep.
Awesome. Awesome. What language do you use mostly?
J2W platform.
All right. Wonderful. So one of the things that I've been thinking about is, how the world has changed. You look like a pretty young guy, so which is good. I've been developing software for a while, and back in time, we would develop software. We would send through applications, would receive data, do processing overnight, stuff like that. Well, one thing that significantly changed, if you really think back in time, this kind of creeps upon us, and we don't really think about this quite often. In the past, organizations typically made their employees available to you. So you go to a bank, what do? You talk to a teller. Well, you used to talk to a teller. You used to talk to a clerk. You go to the reservation system. Well, you go to the railway station to reserve. You would talk to a clerk over there. That's the way the world was. But in the past,
human communication.
Sorry?
It was human communication.
Well, it was a really sad communication. And what has happened in the past about, I would say, 10 years or so, is organizations have opened up their applications rather than their employees, which is a phenomenal difference in the way businesses operate, isn't it? So anybody, just about anywhere, can access those applications and can request for certain information, process it. But not only that, on one hand, as they opened up these applications, on the other hand, of course, we got a lot more of availability on our hand. For example, not only did we have desktops in the past, we then have laptops, now we have handheld devices. And almost everybody that you know of carries a few devices with us, right? What kind of devices do you carry with you?
I do use a smartphone.
Oh, yeah?
And when I go outside, I use GPS.
Okay.
So these are the two devices.
So there are two devices you're using. Well, the person, probably the geekiest person that I personally know is my son. And I quite cannot figure out how many devices he actually has. I tried to confiscate it, I just never couldn't figure out. He's got a smartwatch, he's constantly looking at it, and it's notifying things, he's operating on it, and he's got several other devices, and I have no clue how he gets all these devices, but he's got at any time, if you give a slap, several devices will just fall off of him, right? So that's the way it is. And with this given, of course, one of the fascinating things is, we are now talking about internet-enabled devices. And with Internet of Things, you're going to have people carrying around not just smartphones or smart devices, they're going to have a lot of micro devices. And what's going to happen when you have micro devices? Very soon we're talking about wearable devices, and that means as you walk around, maybe people would walk around with earrings, nose rings, tongue rings, all of that communicating through the internet to applications. And that's going to remarkably change the way we're going to be accessing data, isn't it? So with that said, we got to rethink about the way we are looking at developing applications, which means we have to constantly evolve and change. So I'm assuming you predominantly program in Java.
Yes.
What else do you use?
I use RSA for editors.
Yeah.
And
well, languages. What other languages do you use?
Languages in terms of apart from J2EE platform?
J2EE is not a language. Java is a language. What else do you use?
Okay, I use PHP occasionally.
Okay.
And
we'll still be friends. That's okay.
I'm sorry?
We'll still be friends. That's okay.
And I used to work in C and C++, but that is a long time before.
Okay.
Recently.
You have no memory of it right now.
Tough.
Yeah, I know, I understand.
And apart from that, nothing.
Okay, all right, cool. So I want to start a little bit about talking about something, perceptions. I want you to look at this and see, what do you see here? Are you ready?
Yep.
What do you see there?
I see two human faces looking at each other.
How many people saw two human faces? A few of us. How many people did not see human faces? The rest of them. Well, you know, don't be sure about it. Oh, okay. Some people don't see anything. Or some people see both, potentially. There's four options here, right? Okay. Well, so it's a perception, right? So it depends on what you're seeing. We both are looking at exactly the same thing, right? Everybody in this room is looking at the same thing. But not everybody is seeing the same thing. Some of us are probably seeing that black structure right there, and others are probably seeing two human faces right here facing each other. So it really depends on what each of us saw. Well, that's kind of what happens to code quite often. Two people can be looking at the same piece of code, they may not be seeing the same thing. I was teaching a course, and it was very fascinating. There were two people in the room, and at about the same time, one person said, "Wow, this code is so concise," and the other person said, "Wow, this code is so verbose." And both of them looking at exactly the same code, coming up with a different perception. So we all deal with this kind of perception all the time. And our perception is often limited by what we are familiar with. In that particular example, that may not be true, but in a lot, when we look at code, it really leads to it. For example, here is a piece of code. So if you take a look at that code, and I've shown this kind of code to a lot of people, and you would be surprised how many people come to me and say various different things looking at exactly the same code. For example, I've had people come to me and say, "Oh, that looks like Scala code." And, well, yeah, you could say somewhat like that. I've had people come to me and say, "That looks like Groovy code." And in fact, 2 days ago, or maybe 3 days ago, I was in Western Virginia, and one guy came to me and said, "Oh, that looks like D3. And I said, "I don't know what D3 is." And he said, "Oh, D3 is a JavaScript library." I said, "Of course I know what D3 is, a JavaScript library, but why would you compare a language syntax to a library syntax, right?" That threw me off. And he said, "Oh, this is just like D3. And it got me thinking, we know something, and the immediate thing we do when we look at something else is we immediately relate back to what we have already seen. So I can't tell you how many times people come to me and say, "Oh, this language feature was stolen from," and then they would refer to something else they actually know, and they are convinced that that's where it actually came from, because that's what they are familiar with. So this heavily limits our perception on what we do, how we look at it. Well, let's talk about a few things about my own limitations and how things can be surprising. Well, so here is a wonderful vegetable, and of course, we could ask the question, what is it? Well, what this is really, if you really ask the people that I run around with most of the time, they would tell you this is called an eggplant. And you look at this and say, "Eggplant, did you just start by saying it's a vegetable?" And I'm a vegetarian, so I don't have eggs, but I don't mind having eggplants. But how in the world this could ever be an eggplant? I mean, you can sit there and kind of look at it in different shapes and, positions. I don't see eggplant in there. Well, it turns out this actually is called an eggplant because a variety of this looks like a goose egg. And so this was given, a farmer decided to call this an eggplant. And in fact, this is exactly the name we use in the US and in Canada and Australia. So this is exactly the name we actually use. But here's a question for you. What language do you speak, by the way?
Tamil. That is my mother tongue.
All right, then mine too. So what do you call in Tamil?
Kathirikai.
Okay, very good. I suppose that's correct. What do you call it in English?
Brinjal.
He says it's brinjal, right? So that's what he said, it's brinjal. And that's the name we use. Great. Well, that was easy. But I asked him, what do you call it in English? And he said, without missing a beat, brinjal. Well, I was actually in a foreign country with people from multiple places, And it so happened that I was talking to one guy from the UK. And we were just talking about stuff, and I don't remember why we ran into this conversation. And then he kind of joked and said, it's kind of funny that, and he pointed to a picture and said, it's kind of funny that, that would be called as eggplant by you guys in the US. And I laughed and said, yeah, that's kind of funny that they call brinjal as eggplant. And he said, what the heck is a brinjal? I said, you got to be kidding me, right? You don't understand what a brinjal is, and you think you're English? And he said, I don't have a clue what you're talking about. And I felt totally betrayed. And I said, well, that's brinjal, obviously, right? He said, of course not. It's aubergine. And I'm like, okay, so clearly we are mistaken. If it's aubergine, what in the world is brinjal? And so I immediately had to send an email to my uncle, who is a professor of English, and said, okay, help me out here. I told this English guy that brinjal is the English, and he laughed at me. And he said, it's aubergine, what's going on? Does anybody know? Clearly it's not English, then what is it? And everybody, you can walk on the street and ask them, what do you call it? What are they going to tell you? It's brinjal, right? But it's not brinjal, it's aubergine. Then why do we think it's brinjal in English? It turns out it actually is a Portuguese word. It's not even English. And we've been using this word as English for a very long time. And how naive is that, right? So we've been using the word brinjal, but apparently brinjal is not an English word at all. It's actually a Portuguese word, but it gets even more interesting. Then you can ask, well, how does the Portuguese word come? It apparently comes from the French word. And you can ask where the French word comes from. That comes from the Arabian word. You can ask where that's coming from. It comes from Sanskrit. This is a total loop, right? And it turns out both aubergine and brinjal have the same origin, except they took two parts of the word and they ran with it. And so if you really start asking this question, what are the roots, you end up with a very different answer than this misperception we normally carry with. So that was pretty fascinating for me. Even a little example like this really shows that we are pretty damn ignorant most of the time, and we perceive things very differently. So things get very interesting when we go beyond this obvious, but usually what hits us first is the syntax. But the minute we look at a syntax, we are like, oh, I don't like this, or I like it, whatever the perception may come about. Well, I've never learned a language where the syntax did not take effort to pick up. It's one of the things that's the most difficult in the beginning when you're really learning a new language. But it really gets a lot easier when you start learning languages very frequently, and then it doesn't really bother you as much. But sometimes it can affect the best among us. For example, here's a tweet from Michael Feathers. It says, first glance, I usually hate the syntax of new languages, especially when they are C-derived with pointless syntactic variations. Start fresh, he says. So this is a very natural tendency. We kind of get averse with syntax. But I started looking for various things that people normally say, and here was an interesting observation I noticed. It said, Ruby is awful language. I hate natural language syntax. Yes, I'm looking at you too, AppleScript. So let's talk about that for a minute. Ruby, I love languages. I program in about 12 different languages. I can come close to programming in several of them. And I really, really like languages, and I admire languages. And Ruby is one of the languages I really love for a number of different reasons. One of them is that I'll start out with a little example here, which is pretty fascinating if you really think about it. So for instance, let's say we have a class that I want to start with, and I'm going to say this is my class, let's say car for a minute. And I want to create a new instance of this car, so I'm going to say car equals, and then when I'm done with it, I'm going to print the car. But how do I create a car object? Well, what do you use in Java to create a car object?
I use a new.
Use a new. Well, we're going to use a new as well. And you write it like this, right? Car dot new, right?
Nope.
No.
Other way around. It's a new car.
He says it's a new car, right? Yeah, of course. Why would you want an old car, right? It's a new car. Well, when you say new car, there's a flaw in it. Do you know what the flaw is?
No.
One wonderful object-oriented feature doesn't exist when you say new like that.
Well, I can't identify that.
Polymorphism. So new is totally non-polymorphic. It is statically bound to that particular call. Yes. In fact, one of the mess we deal with in Java is the factories after factories. And all that is there to just work around this particular problem. But if you really look at Ruby, Notice we did not say new car, we said car.new. There's a really important reason for it. And the reason for this is that car is actually, new is a polymorphic call. What that means is, I can do this. I can say class, for example, equals car, and I can come back here and say class.new, and so this becomes a new, becomes a function on the object, where the object is the class itself. Now imagine a factory method already baked in. You don't need to create endless factories like we do in Java, right? So when you start looking at the code, you don't say, oh, you don't say new car, you say car.new, I hate it. Well, you begin to ask the question, why are we saying that? What's the difference? Another thing that fascinates me a lot is, if you really think about this a little bit further, if you go back to this class for a second, let's say car, and I'm going to say in this case I have a miles for a minute. Now I have created a car object, so we'll say car.new, and I'm going to say car, let's go ahead and print the car information. I'm going to say dot, let's say inspect. Now once I inspect this car, you can see that's all it contains. Now this is another very fascinating thing. If you say car.miles equal to 0, now you say car.inspect, notice the difference now. It is exactly the same object, but just a moment ago that object did not have the field called miles, but now that you specified the value for the miles field, all of a sudden the miles field comes into existence. What this fundamentally means is, at the runtime, two objects of exactly the same class don't have to really carry all the fields. They can vary individually from each other. This is a concept we definitely have no clue about in Java, for example, right? Because the minute you create an object in Java, you create 1 or 1,000 objects, every single one of them have all the fields, whether you want it or not. Whereas here, objects are so dynamic, they can acquire fields as and when you are beginning to use the field, and that changes the way you look at things very differently. But let's go a step further even beyond this. In Ruby, almost everything that you deal with instantly becomes an expression, which means I can do something like this. I could simply say puts over here, and I can display the value of this particular class, if you will. So as you can see here, it printed 2. But if I were to say self from here, it actually returns a car. So class itself is actually an expression. So much like your functions. And if it's an expression, what can you do with it? Well, you can start altering it and putting more polymorphic behavior into it, and the language becomes extremely flexible, where you can really work closely with the language. This just bends your mind in terms of how you can work with that particular language. So to me, when I start looking at languages, I don't really care about the syntax. I'm very keenly interested in, what are you really providing for me? What does this really mean to me? That becomes pretty exciting. This is true even when you look at a language that evolves, and most languages continue to evolve. Well, here's another statement I came across. I hate to say this, but Clojure seems to have a bizarre confluence of beautiful semantics and ugly syntax, which reminds me of Perl. That's pretty a drastic statement. But once again, I would argue this is one of the things I really, really enjoy, because if you look at a language like Clojure, you can define, for example, a max of 100, for example, and here is a value that I've defined within Clojure, and I can say this is the value max, and it prints the value that's going to provide for us. Maybe I should say my value to not collide with the values there. So you can see that in this particular case, I've got a value that I'm displaying. But one really interesting thing about Clojure, well, let's talk about Java for a minute. So here's a question for you. I don't want to modify a variable in Java. What should I do for that?
Modify in the terms of...
I don't want to change the value.
You just need to create an instance of that particular class, and then...
No, just a variable. I don't want to ever change it.
I'm sorry?
I heard that final, right? So you want to make a variable final. Well, you have to put an extra effort to make the variable final. Well, in Clojure, every variable is final. You don't have to do anything. You can tell me, well, go change the variable, my value for me, please. Sorry, I cannot. It is baked into. So these are called safe defaults. In the case of language like Java, the safe defaults are unsafe. It's mutable by default, but you got to work your way towards making it immutable. On the other hand, Clojure, everything is immutable by default. Well, you say, all right, this is great. That's one thing that Clojure provides. But if you go a step further from it, well, immutability, conciseness is another evident. But one of the things that really is charming in Clojure is the separation of state from identity. Separation of state from identity simply says, here is the state of the object, and the state is immutable. We just saw that. You cannot change anything when you create it. But the identity is mutable, but the identity is very well managed by the threading under the hood. So for example, I can create a special type here called a reference type, for instance. So here I'm going to say, this is going to be a reference value of 100, let's say. And you can see in this particular case, I'm going to create a reference value. That's basically the type that I'm creating on my hand right here. And once I create a reference type, what can I do with it? Well, I want to change the value, but first let's get the value of 100. So that tells me the value is 100. But I want to go ahead and print this one more time, and then I want to change it, and then I print it. So I'm going to say ref set, because it's a reference type, my value to 1,000, and you would notice that it doesn't let me do it. It gives me an error, illegal state exception. So as a result, what's going on here? If I want to modify this, let's think about this for a minute. So you program in Java, so I have two threads coming in, and both the threads want to modify exactly the same variable. Well, it's quite possible that I would run into some kind of a problem. What kind of problem would I run into?
It is basically called as your, the thread will be locked. And
there's no locking, right? So two threads come in, they both want to modify the same variable. What's the problem I have on my hand? Race condition, that's correct. So to prevent the race condition, what should I do? Synchronize. Well, I forgot to synchronize. What's going to happen? What was it? What will happen if I forget to synchronize? Come on, come on, come on. You got to be kidding me. What was it? Non-deterministic. You have no clue. Admit it. It's okay. You're busy coding, right? The boss comes to you and says, how's it going? What's the right answer when you're doing this? Boss, I don't have a clue. Thank you for hiring me. Right? You have no clue, right? Because if you don't synchronize, does the compiler give you an error? No. Does it give you a warning? What does it do then? It sits there and watches you. And I'll tell you, in the night, all the JVMs get together and they laugh at us, right? They say, what are these programmers thinking, right? Well, wouldn't it be nice if the language came to rescue us, right? Notice I did not put synchronize here. Rather than laughing at you, what did it do? It said, I'm sorry, I'm not going to let you run this code. And you have to say a do sync. And now notice there was no problem. So the language enforces concurrency practices for you, rather than letting you compile the code and get together and say, hey, let's compare notes. What did your victim do today, right? That's what Java does, right? They compare notes and say, what did that programmer do? And they just laugh. If you ever show up very late into work, you'll hear all these laughter. That's where it's coming from, right? The machine's laughing at us. So that's one of the things that fascinates me. Once you get beyond the syntax, that's pretty amazing, isn't it? So given all of this, this person says, there are days when I truly hate Scala syntax. Oh dear. Let's talk about that for a minute. Let's talk about what Scala can do for us. Again, Scala is extremely concise, but one other thing that's pretty darn interesting in Scala is, I can say, for example, val, let's say greet equals, and I'm going to say, let's say greet, hello, and I'm going to say greet. So right there, I create a little message called greet, and I'm going to go ahead and print this greet. So let's go ahead and run this. You can see that in this case, it's running through and printed greet. So question for you, what is that?
It's a hello world to me.
Well, but what have I highlighted? What's that I've highlighted?
That's an XML string.
See, notice the word he used. It's an XML string. How many of you have put XML into a string before? Come on, be bold. Everybody here. I know why you're not raising your hand. Because you feel bad about it, right? How would you feel when every time you have to go out, they put you in a string, right? And you're like really depressed, isn't it? You know what? I really wanted to go around this world freely, but they put me in a string every single time. And if they put you in a string every single time, what would you try to do? You'll try to escape, won't you? Now you know why XML misbehaves. We've been putting it in a string every single time, right? Well, Scala says, let's give XML some real respect it deserves. So I removed the shackles around it. Now let me ask you this question. What am I looking at right now?
This is an XML.
You see that? It's XML, no longer an XML string. So we do XML processing quite often in our enterprise applications. Well, we can start using that very, very effectively. One of my favorite features in Scala is the ability for pattern matching. So I can say catch, for example, right here. I can say greet, and I could say here is a message I want to extract from it, and here is my greet. And I can then say, hey, why don't we just print out what the message is? And you can pretty much go through this very easily, and you can start extracting contents out of this very easily at runtime. Notice we didn't have to go through an XML parser. That becomes a very natural syntax of the language, facility of the language. So again, once again, notice that when we go past the syntax, we begin to really see what languages can provide for us. In fact, the gentleman who said this actually nailed it. I kind of hid the other part of what he said, but I think it's very important to look at the rest of it. He says there are days when I truly hate Scala syntax, or more correctly, he says, I hate that I can't easily unwire my own Java C syntax comfort zone. I think he pretty much nailed it. This is the problem most of us are having every single day, that we are in a comfort zone, and it's very difficult for us to look at something that's different from what we are used to. I couldn't have said it better than he did. So the very first thing we need to do is we have to really get out of our comfort zone. So when it comes to languages, this is what I recommend. First, learn the semantics of the language. The only way you're going to learn the syntax is by practicing it. I never ever learned syntax. When I teach courses on programming languages, not a single minute I spend explaining what a syntax is. And I've done this for a long time. And not a single day anyone in my class ever comes to me and complains, you never taught me the syntax. They're just naturally sitting there, understanding and focusing on the semantics, and the syntax kind of naturally flows in. When they start writing code, they struggle. They look at an example and say, oh, it's an arrow over here, a curly bracket over here, and they figure this out. About the third or the fourth time they do this, they don't even think about it. When I start learning a new language, I can never remember the syntax, no matter how many times I read it. But I start coding it. I struggle with it. About 2 or 3 weeks later, I quietly start coding. I never seem to think of the syntax. But if you don't know what the semantics is, you can very rarely make good use of what's in there. So a true appreciation and understanding of the language emerges when we dig into the semantics of the language and not just the syntax of the language itself. That is something for us to keep in mind. It's very important for us to give credit to the semantics and not really focus as much on the syntax. But let's dig into a little bit of a semantics here. So let's talk about a few things we normally do in Java. You're aware of the Singleton pattern.
Yep.
What is the Singleton pattern?
It just creates only one instance per JVM.
Notice the word he used, the word just. Usually, that's a word we use, right? He's laughing. It just needs a single instance. It turns out Singleton is one of the most difficult patterns to actually implement. And so, let's look at one example of this real quick. I'm going to go back here and say, here is a class called the Singleton. So I create a Singleton over here. And of course, we have an object. We have a class. I say new Singleton, and I'm going to create an object of the Singleton. And of course, once I create the object of the Singleton, I'm going to simply display that Singleton. So if I go ahead and run it, you can see the object. You say, wait a minute, I don't want you to have multiple objects of the Singleton. So if you notice, when I run this code, I've got 2 objects. Oh, darn it, I don't want 2 objects. It's got to be just a Singleton, right? So what should I do? Well, I'm going to say, go back to this and say, well, private, and I'm going to say private. And what should I do with this particular singleton? I'll say static singleton, and then we'll say instance. We do that all the time, right? This is the normal pattern we see. I'm going to write the constructor for this. Well, I will promptly make the constructor itself private, so you cannot create an object of that. How convenient. And then what would you normally do? Well, you would provide a method, for example, public static singleton, and you would say get instance in this case. And the instance you would create, you would say if, for example, in this particular case, if the instance is equal to null, you would then go ahead and say instance is equal to, and this would be the new singleton. You can access the private from within here and return the instance. So as a result, the benefit here is you cannot call that directly, but you can use a singleton by providing the instance. So you could say singleton dots, for example. So you could say singleton in this case and say I want to call a function called foo on it. So you could directly call the function foo. Let's go ahead and say output, let's say hello. And if this is not a static method, how would I go about accessing it? Well, you would say singleton dot get instance, and then you would call that particular method. Well, this seems like a good idea, right?
It is still not singleton.
This is not a singleton?
Yes.
Why is it not a singleton?
There are two problems in this. One is if you have a multi-threaded environment, you fail. And if it is a multi-class loading environment, you fail. And if it is a multi-node environment, you fail.
So you said there are two problems and you gave me three. That's what singleton does to you, right? So you're starting with two, and then as you're working on it, you keep going, right? And he just stopped, but if I let him go, he would give me like a list of 10 things. You are absolutely right. There are that many problems in it. I couldn't have said it better, right? He nailed it. So what do? Well, in Java, we can use an enum instead, which is a bit stinky. But if you really think about this, here is Scala. I can say object is singleton, and I could create an object of this particular class. Here is a singleton. Then I can say define foo, and I'm going to say here is, I'm going to just print out, let's say, hello, in this case. And I'm going to simply say singleton.foo, and I'm going to run it, and that solves every one of the problems you mentioned just a minute ago, right? So when this becomes a feature of the language, then you are saying, I don't have to sit there and attack each one of these problems. There is not enough time in a day. I'm going to let the language deal with it. This is not a syntactical issue, right? This is a semantical issue that we are dealing with. And Scala says, I'll deal with this for you automatically without you having to go through it. What about checked exceptions? So let's think about this for a minute. What do checked exceptions do for us? Well, if you recollect, Java has two kinds of exceptions. One is a checked exception, the other is an unchecked exception. Now, it turns out a checked exception is actually a feature of the Java language, not a feature of the JVM at all. The JVM doesn't really care about checked exceptions. But you always have to fight this problem when you constantly deal with this, right? For example, I want to say implements clonable, let's say, and I want to implement a clonable on this particular class. So how do I do this? I'm going to say public object clone, and within this I'm going to say super, and I'm return maybe super dot clone, and I'm going to go ahead and call that super clone right here. Now, is that enough? Clone not supported exception, but I am supporting clone.
The JVM is not supporting for UNO.
It is not.
The compiler is not supporting for UNO.
That's why I'm writing it. You see the problem, right? Have you ever looked at this and said, well, what do you want? And the JVM says, you need to throw clone not supported. But you're saying, but dude, I am supporting clone. Do you ever get into this problem? You're having this conversation with the compiler, right? And eventually who wins? The compiler does. And what do you say? You say, fine. Are you happy with it now? What is going on here, right? So we are again dealing with an interpretation of the language saying, well, if an exception were to happen here, you have to throw, but it's pretty darn meaningless at this particular point. And what is the result of this? a lot more verbose code. And what do most Java programmers do? They get tired of doing this over and over. And then eventually they say, you know what, I don't have to deal with it. And one of the beautiful things today is we have wonderful IDEs available to us, right? We don't have to sit and write a lot of code. So eventually you figure out there's a very easy way to fix it. The IDE says red, you don't even think about it, right? You click on it, you do this, and you walk away. And you end up with a lot of empty catch blocks. How many of you have seen empty catch blocks in your code? What do you think? It's a great idea? No. Where did that come from? Right? From hell, right? That's what you're seeing right there. Well, that is an example again of how things go really bad. Well, let's talk about threading for a minute. So I need your help here. So shall we talk about threading again? So here's my question. I've got a very little example of a code. Let's go ahead and call it as sample. And in this particular case, I'm going to define, let's just simply say I have a static variable. So static, private, Boolean, we'll call it done equals false, right? Great. Now I'm going to say in here, a new thread. So I created a thread. We'll assign it to a variable real quick. So that's my thread variable. Then I'm going to say over here, thread.start, and I've started this thread. Then I'm going to say thread.sleep. I'm going to sleep for a second. And in here, of course, let's just do that. And then I'm going to simply say done equals true, and I'm going to output done set. Well, within this code, let's go back and say new runnable, and let's review what we just did. So I'm going to say while not done, I'm going to say count plus plus, and then when I'm coming out of this, I'm going to say done. Let's say exit. So right here, I'm going to say within this, int count is equal to 0. Let's review this code for a minute, right? So I have a Boolean variable done, which is false. I come into this thread. While not done, keep incrementing the count. In the meantime, the main thread says, sleep for a second, set the variable to done. So 1 second later, the done is set to true. And what does this guy say? Hey, while the done is not done, keep going, but if it's done, print exit and get out. Reasonable, right?
Yes.
What do you think is going to happen?
Well, the basic idea is you'll be seeing exit a bit later after the second.
All right, so he says you'll see an exit after a little bit later, after that a little delay. What do you say? No, you will not see it. Why not? Why won't you see it? So there are many solutions now. One guy says use join, another guy says use volatile, right? And another person says it'll be done. So which is the right answer? None of it is the right answer. Never be confident about your answers when it comes to multi-threading. That's the first lesson you learned, right? He doesn't want to give up. Do you see that? That is the sign of Java programmers. They are relentlessly hopeful, right? Volatile, volatile, volatile. Then what happens? Performance problem elsewhere, right? Well, Alexander Popovsky nailed it in his little tweet. In theory, multi-threading looks like this. In practice, it looks like this. And we see this all the time, right? Things just go haywire. And we're like, why doesn't this work, right? So if everything was like this, it would be really nice. But that's not the way it really works, unfortunately. I want to work with the list. Let's go back to an example of a list for a minute. So in this example, what I want to do is I want to say here is a little sample class. So I want to start out by saying in this example, I want to create a little list. So let's say list of integer, and I'm going to say numbers equals, let's say new array list. And in this particular case, let's say, go ahead and say this is going to be arrays.as list. And I'm going to say these values, right? So these little values that I want to work with. So given this list, I want to simply say on my hand, one of the things I want to provide is just a remove method. We'll come to that in just a second. So let's go ahead and see how this is going to actually work with a little code here. There we go. Let's fix that. So let's say I want to get the size of this. So numbers.size. Well, you can clearly say there are 6 elements in this list. Then I say numbers.remove, and I'm going to remove 0. And then once I remove it, I'm going to ask him numbers.size, and what do you think it's going to be?
Should be 6, but should be 5, but it is 6.
Well, you did it. It's not 6, it's 5, right? So it is, we removed one element, right? That's exactly what it should be. Don't suspect Java when it's working. Right? Poor Java, right? I know it's done bad things to you, but you shouldn't be like that. But it's exactly the same code, but I changed it to a collection. Now notice in this particular case, the result is going to be absolutely different. And in this case, it's 6 and 6, which is what you were suspecting before. But is this a syntactical problem? Well, absolutely not. It's a semantical issue, isn't it? Now let's continue a little further. Most of us program in imperative style, don't we? So let's take a look at one example here. Find the total of the square root of the first n prime numbers starting with the value k. So let's start with this little example and see how we're going to do this. So I'm going to start with a little example of, let's say I want to find a prime. Let's start with a little simple problem first. So I'm going to say for int I equal to 0, I, let's actually 1, I less than, let's say 6, I plus plus, and I'm going to simply ask him to output is prime for the value I. Well, let's go ahead and implement is prime. We're all used to knowing how to implement is prime. So this is going to be a method we implement, let's say Boolean number. And what should I do here? I'm going to say return number is greater than 1. Then we say iterate over, and I'm going to say this is a value which is going to be less than the number given. We'll start with a 2. And this is called the imperative style, right? And then what do we do here? We say if the value number mod I is equal to 0, well then simply return a false. So this is a very straightforward implementation, but this imperative code, hey, it's working. But what I really want to do is write another function, which is where it becomes a little bit more hairy. So I want to say output total of square root of, and I'm going to start with, let's say 33, and I want 100 values. So how do I implement this? Let's give it a try. So here is my total of square root of. It's going to start with the value double value. This is going to be starting. This is going to be a count. What's the very first thing we would do? Return total, right? When we are done with it, we'll say return total. Great. But in this case, we're going to say, first of all, we will say int, or double rather, total equal to 0. But then what should we do? We will first start with int, index equal to starting. Don't we do that? And then what do you say? Int counter equal to 0. And then while counter is less than count, then within this you will say if is prime, the value at index is actually a prime, then you say the total plus equal to, and math dot square root, and that would be the value that you are interested in, index. Are we done?
Looks like.
What should we do? Increment the index. So I should say index plus plus and counter plus plus. Is this correct?
Well, yeah.
Yes? Well, it appears yes, but this counter has to be here, isn't it? Not outside, but inside. If you put index plus plus here, or if you put counter plus plus outside, the code is broken. Would you agree?
Yes.
Is that a complex code or a simple code then? What do you
Complex
think?
answer.
Oh, it's complex?
Complex answer.
Is it a complex code? Don't twist my question. Is it a complex code or a simple code? You're in denial. You don't want to admit it, right? If you're staring at it, if you're worried it's going to be wrong, is that still simple? No. It is complex. You have done it so many times. How many times have you written less than and you stop and ask, is it less than or less than or equal to?
Every time.
Every single time. And the day you didn't do, what happened? You get the off by one error. Remember that? How painful that is, right? So in this case, of course, I said counter plus plus because I found the value, index plus plus, return. Let's go ahead and try this. So I'm going to call this one more time and see how it works. So run this code, and what happens in this case? It gives us the result, 1660 plus whatever, right? But look at this code. You had to tell every single step what to do, isn't it? That is called imperative code. You've been doing this for a long time. How does it feel to write that code? It is like this. Programming in imperative style is like training a dog, where the dog will never learn from you. Some of you probably have had dogs like this, right? It's frustrating. Every morning you fight with the dog because the dog refuses to learn, right? And that's how it feels, that you got to communicate very, very extensively with the code. It becomes extremely painful, right? Well, let's see if we can do this a little differently. Let's just chip away one at a time. Let's take this code for a minute and say, I want to be talking to this more intelligently like we talk to a grown-up human being. So what am I going to say? First of all, return number is greater than 1, and I'm going to say int stream dot range from 2 to number. And what should I say here? Well, tell me none of these values match given a number that I have in the range mod I is equal to 0. So run this code, and you can see that produces the same exact result, but we wrote in a more of a functional style. You tell it what you want rather than trying to sit through and do every single line of code. It becomes a lot more expressive, as you can see. So even though both of them are syntax in the same language, semantically they are very different in how we communicate with it. That's one improvement. But this code, of course, is really, really troublesome, isn't it? It took us so much effort. Let's retry this. And I'm going to now say, in this case, stream.iterate. So I'm going to iterate through these streams. Where do I start the iteration? At starting, and given a value plus 1. But let's see what I did not do so far. I did not create index equals to. I did not create counter equals to. Normally, honestly, you don't call it counter. You give a different name for it. Do you know what name you normally give? Temp. True or false? You give a name temp. Why are you giving a name temp? You're saying you are not important to me, right? Those are called garbage variables. Well, if a variable is a garbage variable, get rid of it rather than giving a name temp. It feels really bad. Right? So now what are you saying? Filter stream, in this case, a sample, and I'm going to say, in this case, is prime. Then I'm going to say, well, now that I've gotten the values, do a mapping operation, and I'm going to say math square root, but give me only certain values, limit to me a value of count. Did you notice that? You said limit count. Not less than count. Not less than or equal to count. It's count, damn it. There is no ambiguity there, right? It's extremely clear, very expressive, very much programming with intention at that point. And then you can say dot reduce that to, starting with the 0, I want to double off the sum, and I want to eventually return that result from this code. And of course, this is a syntax we got to get used to, but if you're really after the semantics, it's much easier to adopt to this. So we don't have all that fluffiness. Here is another big advantage. When you look at the top code, what do you normally do with the top code? If I were to ask you, what does the top code do? How do you go about figuring out what the top code is doing?
I have to interpret it and then have to say that.
He's got to interpret it and look at it, right? Do you look at it like you say, while, and then you get into the if, you look here, there's a break, there's a continue. Does your eyes go back and forth?
Yes.
It does go back and forth, right? In fact, it's even more fun. Maybe you're looking at this code in the middle of the day when your business analyst comes to you and says, hey, what does this code do? What do you say? You say, that's what I'm trying to figure out, be quiet. Right? On the other hand, when you look at the code below, it is a single pass. Would you agree? It's a single pass. You start at the top, you get to the bottom, you're done in one pass. Start with the stream of all the numbers with the starting, get me only the prime numbers, do the square root of them, but only get me 100, or count whatever that is, and find the sum of it. It's a single pass. The code begins to read like the problem statement, and as a result, you're able to get this done. However, there is a very deeply rooted semantic meaning in this code, which you cannot figure out looking at the syntax. Do you know what the deeply rooted semantics here is? Not a function, something else. It's not a lambda, even better.
It's a builder.
It starts with L, but not lambda. Lazy, that's correct. It is lazy evaluation that's being used here. If you don't see laziness, this is very difficult to see what's going on in this code, right? And that's why the laziness is not written for you to see. You have to read in between the lines to figure out the laziness. Because you're working with an infinite series here, the only way this can work is if it is actually lazy. So that is the point, is that we have to really look beyond the syntax. One other problem we normally run into is, when this is a common thing we do in code over and over and over. We bring two different things together into one place, and that creates an enormous amount of problems. For example, Java said, well, C++, you really have to manage memory all by yourself. That's a really bad idea. We'll give you automatic garbage collection. Great idea. But then they mixed two things together. They said, we will free up the memory for you, but we will do that at our own pace. But if you really want to participate in it, do the finalize method. But what is the finalize for? The finalize is to clean up resources. When is the finalize called? When the memory is cleaned up. Notice the conflict between two things being brought together in one place. If you're managing memory separately, you should not bring that with managing the resources. And now, of course, now that we have the finalize, the best practice is don't use finalize. And then we start putting other constructs around it, but it's a very deeply rooted semantical problem we are dealing with from the ground up. So as we are working with evolving languages, as we are looking at polyglot systems where we're dealing with multiple different languages, it is extremely easy for us to look at the syntax and get very quickly frustrated. But as professionals, we really have to look way beyond the syntax. Because the problem very rarely is in the syntax. The problem and the power is really deeply rooted in the semantics. And once you really are able to see the semantics, you are able to make really good power of the languages. You know what areas to avoid. You know what areas to really leverage. And that only comes from really quickly getting past the syntax. You never ever learn the syntax by reading it. You only learn the syntax by doing it. But the semantics is what you really need to spend the time learning on, and the syntax is something you have to continuously practice. So I'm going to complete this with the words of Henry Thoreau. And Henry Thoreau says something that is for all of us to kind of take away and think about it. He says, it's not what you look at that matters, it's what you see. So don't look at a language through its syntax. Get past that and see the semantics, because that's the scary part. That's where the real power is. And I hope you'll be able to enjoy the power and the pleasures and the perils that semantics offer to us, because that's what the real fun is. I hope you will enjoy that. Thank you. It's okay. What's your... How do you spell your name?
Thank you so much, Venkat, for starting that.
Do we have time for some questions in the meantime?
Yes, we do have a few minutes for questions.
How do you spell your name?
So if you have a question, please raise your hand and we'll have a mic passed on.
A-N-A-V.
Thank you. Thank you. Thank you. Thank you. Come on. Anybody? Oh, there he is.
In that Boolean, if you use, we are encoded on.
You're fine. Go ahead. I'll repeat the question if needed. Yep.
If we use the atomic Boolean in that case, whether it will satisfy your need?
So the question is, if we use atomic Boolean, will it solve the problem? Well, the short answer is no, it won't. And the reason is, so here's the deep-rooted problem. When you're dealing with concurrency, this is what I was ending with saying, when two things come together which shouldn't come together. You're talking about race conditions on one hand. The other problem you're talking about is whether the data is in the main memory or whether the data is in the working memory. And you need to constantly move the data from main memory to working memory. So when people are shouting volatile and when you're asking atomic long, the problem you're really addressing there is again two things together saying, I'm going to push the data back and forth between the memory. The problem is when you deal with an atomic long or a volatile, that only addresses one variable. Well, that's great. It will take care of the problem of moving the data back and forth. But when you have multiple data, you want to make sure the changes to the data are consistent with each other. You don't want to update each data independently. That's when you end up with the race conditions. And so when you really bring the entire problem together, these hodgepodge of solutions pretty much end up breaking. So that's one of the reasons I normally recommend that the JDK library for concurrency is the assembly language for concurrent programming. We shouldn't be coding at that level. We should be really coding at a higher level of abstraction and let those abstractions deal with these lower levels, and then we don't have to deal with those inherent problems.
Hey, so a lot of these new languages, you know, like they hide a lot of complexity within themselves. So, but what are the performance issues? You know, sometimes you really want to juice out your hardware.
Right. So the question is, great, raise up the abstraction level for us. What about performance? Do you have further question continuing, or are you done?
Yeah, I mean, a lot of times, so, you know, they do a lot of temporary objects, classes, and all those things which normally a programmer does it directly. That's what a lot of these languages do at lower level. It hides it from you.
Oh, you're assuming that's an assumption?
Yeah, I mean, that's what I've been seeing, that, you know, all Scala, Groovy, and all these things are doing.
Not necessarily. So we're assuming that these could be poor in performance, but that doesn't have to be the case all the time. One example for this clearly is Java 8, for example, right? Java 8 has raised the level of abstraction, but they have taken enormous pain to make sure it's actually very good in performance. So I would never assume that a raise in abstraction level by definition is a poor performance. That doesn't have to be. In fact, to a great extent, I would argue, if you and I do it, it's easy to get poor performance in the long run. If they do it, they can always come back to optimize it. We call it encapsulation, right? So they can do it and they can make it better if it's not good in performance, but if we're going to do it, we got more than performance as a problem. Most of the time we perceive performance problem much more deep than that it really is a problem, and in the end we end up with poor performance and poor maintainable code as well, and that becomes even a bigger problem to deal with. One more question?
Just I want to check that you speak about singletons and all these functions and all. So why we are not improving on the Java? It was open source earlier, okay? It still is there. So these all functionality, why we are not, like in object we have done this all things. Why we are not doing the basic things in that Java? So you can create a singleton class, how we talk about Scala, right? In that you have implemented, and just you need to call that word, and that will be done your job.
So the answer is, why can't those be improved? The answer is they are improving, but not exactly the ones you and I want to be improved. For example, if you look at Java itself, Java has gone through an enormous upgrade, and where it is definitely necessary in the case of function style of programming. But like you and me, we only have limited amount of time and effort that we can put in at any given time, and that has to be spent very wisely. So you can give them a choice saying, give us this wonderful functional programming capability now with a really good performance, or go back and fix the legacy. Well, I'm glad actually they worked on what they worked. Maybe over time some of the other things would improve, but as we all know, improving legacy is not that easy. It's a baggage we carry with us. And so as a result, there are certain things that will get improved, and there's a lot of things that we just have to kind of live with. That's just the way legacy systems are, and Java itself is legacy in that regard. If we had infinite amount of time and money and resources, we can definitely keep fixing a lot of things, but the reality is that it's not the case. And also, a lot of times, what you and I may perceive as a simple change is really not that much of a simple change at the language level, because that has other ramifications and consequences. And so whatever they may have insight into improving, they often are limited because of the realities as well. Well, I'm going to stop with this. I hope you found that useful. I'll hang around if you have any questions. I'll be delighted to talk to you offline. Thank you.